Okay, so hello everyone. We'll continue with our discussion in chapter 7. I think this will be the last time that we'll be going to be discussing chapter 7. And last time we talked about the acidity of our alkynes. So we are on alkynes already. And we were able to learn on the acidity of our alkynes, and we learned that the alkynes is the most acidic relative to the alkenes and alkanes. And of course, if we have the alkynes to be the most acidic, we've also learned its conjugate base will be the least basic of all. Like the conjugate base of your alkyne, HC triple bond C with that anion here is the least basic of all. Try to compare also the acidity of our alkynes relative to the other class of organic compounds, for instance, the water and the alcohol. Here in the trends, we saw that the alcohol and water, of course, is the most acidic as compared to your alkynes. The alkynes is much more acidic than the ammonia and the alkenes and alkane. So you just have to remember the trend for that, as well as the conjugates base relative basicity. And this you have to review on to know how the reaction will proceed, but basically we only have to look at the pKa value of each of the species, and we always learn from Chem 130 that we always produce the weaker acids and bases from a stronger. Okay, and you can practice this one. It will be the predicted product mode. This is simply like an acid-base reaction, and we started with a stronger acid and stronger base to produce a weaker acid and a weaker base like this one. So for us to predict, we always simply have to remember on or check on the pKa of the individual species. So now we'll proceed with the reactions of alkynes. Okay, the first one is how to prepare our alkynes. So the first way of preparing or the synthesizing of alkynes is via the elimination reaction. It's a similar reaction that we have learned in the alkenes, preparation of alkenes, where you have your alcohols and alkyl halides. It's an elimination reaction, one-to elimination reaction by your, for example, in dehydrohalogenation, you have your proton H and your halides, the halogens, to form your alkenes. Or if you have water, or if you have your alcohol, you have HOH, it can be eliminated to form an alkene. Now, in the preparation of alkynes, it's a similar way, but we have a different starting material. Our starting material is usually a vicinal dihalide. This is a vicinal dihalide. These are 1, 2 vicinal side-by-side halogens, and we also do elimination reactions. These two vicinal dihalides, the halogens in the group 7, for example, the chlorine, bromine, iodine, they are called, if they are situated vicinal to each other, we call this vicinal dihalide, and in the presence of a base, this kind of reaction will proceed via elimination reaction to produce our alkynes here, but we basically have to need 2 base to proceed with the reaction. Okay, so we will see in the next step the mechanism of that. I'm not sure if we have already discussed that, but in case we haven't, here is an example of how to proceed, how to prepare our alkynes by double dehydrohalogenation reaction. We have our vicinal dihalides. Okay, so if, for example, we have an alkene and we don't have a vicinal dihalide, the first step is the preparation of our alkene, of our vicinal dihalides. The first step is a bromination reaction. We have our bromine here, Br2, or halogenation reaction. We have our alkene, and we have not halogens, yes, halogens, no, added to your double bond and produce a vicinal dihalide. And after that, we have a base, strong base like your sodium amide, NH2, no, it can obstruct the proton here, okay, and the electrons from the carbon hydrogen bond will go to proceed with the double bond, and bromine will be eliminated here, will leave. Okay, so you have here, and what you will get is a double bond, and you are left with an alkyl halide. You have a double bond and a bromide and a proton here. So you have another mole of that, then also obstruct the proton here, and leaving the double covalent bond to produce a triple bond, and bromine left. When the triple bond is formed, bromine will leave the substrate to have your Br, and then you get your triple bond. So for the mechanism of that, I have already shared on the mechanism. The first step is, of course, I have already mentioned. Now, once you have already formed your Br, vicinal dihalides, once you have already, this is the general reaction. So the first step for the reaction is you have this first mole of your amide that will obstruct on the proton. Okay, the same way that the base will obstruct the proton in the elimination reaction. It doesn't attack the carbon, but it will attack the proton, the hydrogen. So we use the electron pair from our base, such as your amide. And okay, so you have your electron pair and hydrogen. So you get your dot, two bonds here, and you get another bond, third bond with hydrogen here, you see. Okay, since we use the electron pair to form a bond with hydrogen, the hydrogen will leave its electrons to carbon-carbon to form a double bond. So we have the arrow here. Okay, so once the double bond is being formed, of course, you will have more than 4 bonds. No, it's not possible to have 5 bonds. So bromine will leave, bringing with it the electron pair from the bond. So you'll have double bond, and bromine will leave from 246 and 2468. All the electrons will go to bromine in this bond. Okay, so what is the first product? For this first steps, you get an alkene, and you get your halides. One of the halides left with the double bond, and one of the halides has already left the substrate. Yeah. Okay, the second step is we use another mole of your amide, this amide, and this will be our first product here, will become our starting material for the second step. Okay, so you have your amide, your base here, and your product here will be the one to be attacked again with your base. So it will attack the proton, the hydrogen. So once it obstructs the proton, the covalent bond, or the electrons from the covalent bond between carbon and this proton, will go to this carbon-carbon here to form a triple bond, another bond. And once it forms a triple bond, the carbon-bromine bond will be broken. Once new bond is formed here, so carbon-bromine is broken, and the electrons that comes from carbon-bromine will go to this bromine. Okay, leaving with it. So 246 na siyang 2468 with the electron. Of course, becomes negatively charged. You can go on the formal charge again. So what happens to your amide? It will become an ammonia with 2 electron pairs here. You have 2468 and a negative charge. You can check on the formal charge again. So you have a negative charge amide, and forming a new bond using its electron pair, you will have 3 bonds now with an electron pair. Okay, and of course your alkyne. So in the mechanism for the dehydrohalogenation of vicinal dibromides to form an alkynes, there's actually 2 steps to obtain our alkyne. Okay, so this is still elimination reaction, 1-to elimination reaction, but we don't start with hydrogen alkyl halide, but we start with a vicinal alkyl halide. Okay, so since if you only have this, like, let's see, yeah, we start with a vicinal dihalide to get our alkenes, and then 2 moles of our base. It's a very simple reaction. Okay, so it's very simple reaction. Usually, the base that we use here is amide, the presence of ammonia. Okay, so here it should be 2 equivalents. Initial, yes, you have a question? Okay, in the initial dehydrohalogenation, vicinal dihalide produces a mixture of 2 bromoalkenes that are not isolated but that undergo a second dehydrohalogenation. Okay. So here is 7.3. Screen. So let's have another example, 7.30. Another example of the elimination reaction of a vicinal dihalide. So you see 2 halogens here, vicinal to each other, and amide, it's our base, and ammonia. We actually simply need not 3 equivalents, it should be 2 equivalents. So 2 here. Okay, we have here the first product that you will get is you will get 2 alkyl halides. No, first is you have this the double bond and a Br. So if your amide will obstruct the proton here, okay, the hydrogen here, what you will get is you have this one. Okay, if you obstruct this one, it will form a bond here. Okay, so imagine you have your hydrogen here. And another hydrogen here. You have your okay, this time. Okay, so you have your amide. So your amide comes from this one. This one will produce it is positive and negative. From sodium amide, you get an amide. You have positive and negative, so you have your NH2, no, that comes from your sodium amide with 2 electron pairs. Arrow from that. Okay, you have your dot. You have 2 dots. Anyway, that's 2 dots, no? And of course, there's a negative charge. So if it will obstruct the proton here, what will happen is that this bond will, the carbon hydrogen bond will be used to form a double bond here. Once a double bond is formed, the bromine will leave. Okay, so your first product as a NAC, first one or the second one? If this amide will obstruct this proton here, what is your first product? What would be your product? Is it the first or the second? Is it A or is it B? Anyone? Okay, so it will be A. If your amide will obstruct if this amide will obstruct this proton, okay, what will happen is that the bond between the electrons between this carbon and hydrogen will be used to form a bond, double bond. Okay, so I will just, you have that, and you'll get a double bond. Once that this one forms a double bond, your bromine will leave and it will bring with it its electron pair. So what is your product? If this second hydrogen will be obstructed, is it A or is it B? Of course, it will be letter. So this one is B. You'll get your product here. So you have two alkynyl bromide that will be obtained actually in this kind of reaction, in this, if we have our substrate. And then from that, this is just the first step of the reaction. Okay, so this is step 1. You'll have to proceed with step 2. Kaya pala 3 equivalents. So step 1, you'll have to proceed with step 2. Step 2 is from this one, your first reactor, your first product will become your first reactant. Your first product will become the reactant of the second step plus another plus your amide. Okay, so your amide with electrons that okay, plus of course there's a negative charge there. So imagine you have your hydrogen, here. So you have your hydrogen here, you have your hydrogen here, okay. And then you have your hydrogen here. So what happens is that your amide will obstruct, as I mentioned, will obstruct your proton here. Once it obstruct your proton, the proton will form okay, this one. Once this obstruct this proton here, what happens is that the proton will form triple bond. Once it forms the triple bond, the bond between this carbon and bromine will have to be broken also, and bromine will get your product, will get all rather the electrons. So your product will be will have your 1, 2, 3, 4. 1, 2, 3, 4 carbons. 1, 2, 3, 4. You'll get your tanggal man imong bromine, so you only have 1, 2, 3, 4 gihapon. 1, 2, 3, 4, no, it's a triple bond. You get the triple bond. You have your hydrogen. Okay, so plus your Br. Your Br, of course, na siya electron pairs. 6, so for Br, you'll have your that from 6, no? 2, 4, 6 should be at that here. Okay, you'll get your that that. So you have 8 and a negative charge. Okay. And then this will be your product. Okay, you have a triple bond. The other product will be, we use this, the second one. Okay, of course, you have your hydrogen. So either of the hydrogen, no, you will abstract this. Okay, so if your base will abstract the proton, okay, so what happens is that the bond, the electrons in this covalent bond will be used to form a triple bond. And once a triple bond is formed, then CBr will have to be broken and all the electrons will go to the. So you have your product. So what will be your product? You still get your this reactant, this product here. So you have 1, 2, 3, triple bond. You still get your product, this one. Plus this one. So you actually need 3 moles of that. The first mole is using the first one, using this to form. That's the reason you have 3 equivalents. First mole is to have this, and then the second one, you have this one. So once you have your products form this 1, 2, 3, 4. So dapat straight kasi dapat ang triple bond, no? It's a linear. Dapat linear ito. So 1, 2. Just to show the geometry, so you have this carbon. So you have 1, 2, 1, 2, 3, 4. So 1, 2, 3, 4. So anyway, all of this will lead to the same product there. So once you have your product, okay, and then you have this. Then you can proceed with the base, the amide. Can abstract again your acidic proton here, and you will get your alkyne, the deprotonated one. And then that's why we use the conjugate acid of your ammonia, okay, the NH4Cl, to make it acidic, and you get your 1-butyne here again, this one. Since what happens is that your amide, so you have 2 equivalents, because the third one, you'll abstract this to form this one, the conjugate base of this. So we acidify this again to make it to return to this product. Okay, so it's just a matter of the condition of our reaction. So our final product is again 1-butyl. So geminal dihalides can also be converted to alkynes by dehydrohalogenation. So here is we have your vicinal dihalides, kanang silingan sila, katapad. We also have a geminal dihalides, kanang dihalides that are both connected in the same carbon. So you have this. So first, to prepare our alkynes using that one, we still use our amide, usually from sodium amide, and in the presence of heat, the mineral oil or heat, and then we acidify again. The same way here, we have acidification. This is the process where we acidify using the conjugate acid of ammonia, NH4Cl. So what happens? See, okay, so I just want to emphasize that usually can have this once you have your vicinal dihalides now that is terminal, because once you obtain your terminal alkyne, it's very acidic and you have a strong base, it's easily to deprotonate our acidic proton here with the use of your NH2 here. So you have to acidify it again with your conjugate acid. Let's go to the second way of preparing again our alkynes. It's by the use of a vicinal dihalide. So in that case, if you have your vicinal dihalide, this one, we can obtain our alkynes in the same manner, no? Where we abstract first our proton. Once we abstract our proton, you get a double bond and then halide, and then you have another step, you get a double bond and halide, and then you have to acidify our, then the amide can abstract the protonated the proton from the alkyne, terminal alkyne, and then we can recover that by acidification. We have an acid here, like this one. We put an acid, this is the conjugate acid of your ammonia, to protonate, to donate our proton here. So the base here will abstract the proton here to get your amide here. And that's the reason why you have 3 equivalents of your amide. Okay, and to prepare our vicinal dihalides for here in the vicinal, to prepare our geminal dihalides, we usually use PCl5 or phosphorus pentachloride to eliminate, to obtain our side product PCl3. So do not worry, we'll be using this one once we will be dealing with ketones later. No, one of the reactions of ketones later will be handling the PCl. That's just for the initial way of preparing our geminal dihalides with the usual reactants or reagents to prepare a vicinal dihalide is by the use of PCl5 at a low temperature. Okay. So you have C bond O, this one is being eliminated. The oxygen here is being eliminated. The mechanism of this PCl5 with its reactions to ketone, no, will be discussed when we go sa ketone, I think, in the later chapter. Just for now, as a start, no, just know that the geminal dihalide can be prepared from a ketone, and you have your PCl5. So the C bond O, or the O, will be eliminated, and you get your chlorine fluorine on this double bond carbon here. And you will use the same reagent to prepare our alkanes. So let's have a practice. Show how you might synthesize ethanol benzene from methylphenyl ketone. You will use the same reagent, methyl phenyl ketone. So you have phenyl, C bond O, and then this one. You have this as a ring, methyl ketone. So phenyl, like convert this one into a ring, you have the methyl phenyl ketone, and then you will synthesize ethanol benzene, ethynyl benzene. So you'll get C triple bond, CH you have here. So the first step is just to convert katong with a ring here. You will get your triple bond, this one with a ring here, and this, and then you can proceed with this reaction. You get actually your this ethynyl benzene. So you have a ring here, a benzene ring, C triple bond CH. It will be fun. For 7.21, outline all steps in the synthesis of propyne from each of the following. So you notice here that you have your CH3, COCH3, so this is a ketone. And since we're starting with the ketone, we already know that we need to convert this one into this one, terminal, let's say, dichloride. Okay, so you can convert this into geminal dichloride. Okay, you can convert this one, and from that, you can proceed with this reaction. So how did this reaction occur? Just in case you are curious, you can go back here. Okay, so let's see. You have your amide. No, you always have to go. Sorry, action mechanism. You have your amide here. Convert that. Okay. Okay, so let's na pala. You have your NH2. So your NH2 will come from your sodium amide half. You have your NH2. Of course, you have your electrons. And that. So you will use that electrons to obstruct your protons. Let's just say para claro, no? If we have 2, let's convert this to 2 and 2, and then you have 1 hydrogen here. Okay. So klasiko yung magsama-sama diha. Pau! Klasiko? I'm sorry, yun ako na-mute. So here, we'll attack. So funny. So here, we'll attack our proton again. Where is my pen? We'll attack the proton. I thought na-mute na ako. So once it attacks the proton, what happens is that the bond will go here to form a double bond. And once the double bond is formed, you will have chlorine will get all the electrons.